This fire burned for 48 minutes in a car parked in the Scranton Municipal Parking structure. Ordinarily, the fire would have been extinguished much earlier by the Scranton Fire Bureau, but it wasn't an ordinary fire. It was a test. The first full-scale fire test conducted in a modern open-air parking structure while it was in normal business operation. The Fire Bureau personnel were present throughout the test, but they let the fire burn unchecked to see the effect it would have on adjacent cars and on the exposed steel structure. The test was conducted on October 15, 1972 by American Iron and Steel Institute in cooperation with city officials of Scranton, Pennsylvania. Scranton is an industrial and railroad center in northeastern Pennsylvania with a population of more than 100,000. This modern multi-level parking deck is typical of many now being designed and constructed of exposed steel throughout the United States. It has a 554 car capacity and commercial retail space on the first level. The post-tension concrete deck has a continuous slope for parking and incoming traffic. There's also a circular exterior exit ramp for outgoing traffic. The tarpaulins you see were to prevent smoke damage during the test. Mayor Peters of Scranton, a professional engineer, had these comments to make about the test.
We are happy to be chosen as the first city in the United States to undertake this type of a test where an automobile is set afire in a parking garage, an open-type parking garage, and determine the effects of the structural steel and the structure itself in this garage from this major fire. And of course, from this can result savings in insurance to our particular city and the cost of this insurance if the tests are successful. If the test is not completely successful, at least we have the results of testing being made in this structure, and conceivably in the near future, someone somewhere can be helped, and we hope it is the city of Scranton.
Fire Chief Tom McGowan and the Scranton Fire Bureau were very helpful. The Fire Bureau had previously conducted a series of open-air burn tests at the Fire Bureau training ground, setting cars on fire under the engine compartment, in the interior of the cars with full tanks and half tanks of gasoline, with the windows up and the windows down. The purpose was to determine what conditions would most likely contribute to a major automobile fire.
In the test we've conducted at our training grounds, we have burned 3 or 4 cars there. We've allowed them to burn for up to 45 minutes and completely consume themselves. We've had cars parked next to these automobiles, and we have found that there was no communication. In our test, we had one car with a full tank of gasoline. We had one with half a tank of gasoline. We did have some boilovers of the gas tanks, but they posed no problem. They remained right in the area of the automobile, and we have had no problems in extinguishment of this type of fire.
The Scranton test was designed to show the effects of fire on exposed steel. No changes were made in the structure for the purpose of the test, except to provide thermal protection for the post-tension concrete deck. The exposed steel girders, beams, and columns were not protected. To prevent damage to the concrete, the floor was first covered with 2 inches of sand. Light gauge steel was laid on the stand. Gypsum wallboard was then placed over the steel. To prevent damage to the concrete deck above the fire, thermal insulation was placed on corrugated steel, supported by temporary steel beams. To collect accurate and authoritative temperature data, 40 thermocouples were installed in the structure by Underwriters Laboratories Incorporated. Thermocouples were inserted in the steel girder, beam, and column. They were also installed in a space above the burned car. The purpose of this data was to obtain information about the severity of fires in open-air parking structures and to determine how fire affects such structures. In earlier tests conducted in England, Japan, Switzerland, and at the Fire Bureau training ground, it was demonstrated that an automobile fire is a low-intensity fire, and if left to burn uncontrolled in an open-air parking structure, will not damage the structure. However, the Scranton test is the first test conducted in a large, modern operating structure with full-size American cars. These earlier tests also showed that the use of exposed steel in open-air structures is safe. Temperatures of the exposed steel during fires in these structures are not critical. However, building codes and fire insurance rates have not reflected these facts because they have not recognized that an automobile fire in an open-air parking structure is a low-hazard fire. To provide a continuous record of temperatures throughout the Scranton fire test, thermocouples were connected to automatic recording equipment and checked for operation with flame guns. These men are marking where the test cars will be placed. Three cars were brought into the test area and made ready. All were American-made, late-model, full-size sedans. The car on the right was selected to be the burn car. A third car was also placed to the right of it. Cars were also parked on the deck above the test area to provide typical deck loading. A surveying instrument was set up to measure the deflection of the steel girder supporting this load. Provision was also made for girder elongation measurements. The test cars were parked approximately 2 feet apart. The distance of the burn car from the nearest column was 2 feet 8 inches. The distance of the burn car from the girder was 2 feet 6 1/4 inches. Each fuel tank of the 3 test cars was filled with 10 gallons of gasoline, and the cap tightened. Previous tests showed no significant difference in the car fire, whether the tank was full or partially full. Crumpled newspapers in oil-soaked rags were placed in the front and rear seats of the burn car and the 2 adjacent cars. The trunks contained spare tires and other material normally found there. The windows were rolled down approximately 2 inches because in the previous Fire Bureau tests, the car would not burn with the windows rolled up. Parking Authority Chairman Pat Sheeran offered the use of this new open-air parking facility because, as he put it,
we of the Scranton Parking Authority are most nearly concerned with the problem of fire hazards in certain type building construction for motor car occupancy. And because we're happy to participate in this fire test today to show conclusively that the fire hazards in this type structure and facility are almost non-existent. Through this test, we hope to bring about, through the help of our International Municipal Parking Congress and the National Parking Association, through their help, we hope to bring about a revision downward of fire insurance rates and also bring about a modification in the building codes.
it was a clear Sunday morning in Scranton. The temperature was 41 degrees. A 15 to 20 mile an hour wind was gusting out of the northwest. Mr. Sheeran ignites the paper in the burn car at 0 minutes, as shown on the test clock. Normally, an automobile fire is difficult to ignite. To ensure ignition, newspapers and oil-soaked rags were used. In this test, the fire was started inside the car. In previous Fire Bureau tests, the same burning pattern occurred, whether the fires were ignited under the engine or inside the car.
If you have never seen a car burn from interior ignition, this is very typical. A lot of smoke until the windows break. Once the windows break, we get extra air and oxygen into the fire, and you'll see more flame.
The carpeting, upholstery, and plastic interior is quickly engulfed in flames.
There was a loud crack, probably glass breaking on one of the windows. Light smoke out the right side.
5 3/4 minutes into the test, the rear window of the burn car gives way, and flames begin to impinge on the steel girder.
Now the back window burn, and you can see the immediate increase in the flame as oxygen gets to the interior.
At 7 minutes, the left rear window pops.
This is burning rubber, burning plastic to the interior of the car.
Heavy smoke is emitted and stays close to the ceiling. Because of the wind, the smoke is carried into the structure, but it is soon dissipated out through the open sides. 9 minutes into the test, the left front window gives way. The windshield begins to disintegrate at 10 minutes.
Starting to burn down the right rear door. The interior of the car is now totally involved, and from here the fire will spread forward into the engine compartment and backwards into the trunk area.
The air temperature recorded by the thermocouple in the flames above the windshield fluctuated throughout the test, reaching a maximum of 810 degrees Fahrenheit at 11 minutes. At this time, temperature of the steel girder was 260 degrees Fahrenheit. 17 minutes into the test, the right and left rear tires of the burning car catch fire.
Right rear tires now burning.
Temperature of the steel girder is now 420 degrees Fahrenheit. The clock on the right has stopped, but the clock on the left has the correct time. The black smoke is from the tires. At 20 minutes, the right rear tire of the burn car blows.
That sound you just heard was the right rear tire.
A minute later, the left rear tire blows. The temperature of the girder has now decreased to 415 degrees Fahrenheit. Deflection of the main girder is 3/4 of an inch. Elongation is 1/8 of an inch. The left front tire of the burn car blows at 24 minutes. "26 minutes into the test, the right front tire blows.
If my count was correct, that was the fourth of the tires that's now flat.
Then the gasoline vapors from the gas tank catch fire.
We are beginning to get gasoline burning. On the left-hand side of the car, you can see there is a flame.
31 minutes into the test, the gas tank is totally engulfed in flames. The heated gasoline in the tank of the burn car boils out and burns, creating a flammable liquid fire under the burn car. All of the gasoline is burning away under the car, even though the floor is sloped. None of the burning gasoline spreads to the adjacent cars. The Scranton Fire Bureau received many phone calls from concerned citizens wondering about the fire. They were told it was a test and not to worry, even though the parking structure was open for business as usual, as if no fire test was being conducted. At 37 minutes, the plastic taillight of the right-hand car starts to burn. Note once again that the right-hand clock has stopped. Fire Bureau personnel are standing by. They are not wearing breathing apparatus, since smoke and heat remain near the ceiling and are dissipated through the open sides of the structure.
You will note that the fire has sort of reached a constant level of intensity at this point.
At 41 minutes, the temperature of the steel girder has reached its maximum, 440 degrees Fahrenheit. At 42 minutes, the exposed steel girder has also reached its maximum deflection, 1 5/8 inches. Deflection of the girder during the test was caused by thermal expansion of the bottom flange. Maximum elongation of the loaded girder was 1/8 of an inch. Note that the taillight of the right-hand car has burned itself out. 45 minutes into the test, the spare tire in the trunk of the burn car blows, emitting dense black smoke.
Once the fire has reached this point and everything is stabilized, there's not much sense of letting it go and go and go. It'll just make a lot of smoke and it won't get any worse.
It's now 48 minutes into the test. The fire has settled down and the temperature and deflection readings of the steel girder are decreasing. Temperature of the girder is now 410 degrees Fahrenheit, down from a maximum of 440 degrees. Deflection is 1 1/2 inches, down from a maximum of 1 5/8 inches. Both deflection and elongation returned to zero after the steel cooled. Fire Bureau personnel moved in and extinguished the fire in 2 minutes using light water from a single 1 1/2 inch hose. Water fog is also frequently used to extinguish automotive fires of this nature. After the fire in the test car was extinguished, flames were observed in the left-hand car. This fire was quickly extinguished by Fire Bureau personnel with little damage to the car. A careful check after the fire test revealed no damage to the exposed steel. Eyewitnesses were asked their reaction to the test. Gerald E. Lingenfelter, engineer, American Insurance Association.
I was surprised at the amount of smoke which was evident. Potentially this could be a hazard. I think about this, though, with regard to enclosed garages more than I do open air as being a problem. But it is something that I learned from the test.
Eugene J. Fasulo, Chief Structural Engineer, the Port Authority of New York and New Jersey.
Having this type of a test demonstrates the viability of structural steel as a competitive material to keep the cost for parking garages as low as possible so that they can be built at the facilities and serve the public.
William H. Coriali, Technical Director, Polytechnic Institute of Brooklyn.
This test this morning is one of a large number that have been going on around the country, and they are very, very effective in furnishing us with background information and scientific information to help us keep these building codes up to date.
John P. Townley, Chief Fire Department, Plainfield, New Jersey.
It illustrates the fact that you don't have to worry too much about your unprotected steel in the open-air parking garages. We've felt this way for a considerable period of time, but we've not seen a true demonstration, a true full-scale, true-to-life type demonstration. In fact, it went beyond a little bit because I don't think that you would have a total burnout of an automobile as it happened here.
W. Robert Powers, Superintendent, Fire Prevention, New York Board of Fire Underwriters.
I think this test showed that the severity is not as great as anticipated, and that it was very plain to see that there was not impingement of flame or serious hazard as might normally be expected.
James W. Shaw, Professional Engineer, Ramp Engineering Associates.
I think that we can now prove to the skeptics that the parking garage is not the fire hazard that they have claimed it is for years. I think now we can design more efficiently and more economically for the future.
Harry J. Franson, Executive Secretary, Board of Building Standards and Appeals, Cleveland, Ohio.
The temperatures on the structural steel were less than 500 degrees. We observed that there were some normal deflections caused by the increase in temperature of the structural elements, that is, the slab columns. In general, we've been pretty much impressed by the performance of the structure as it relates to fire exposure.
William D. Heath, Executive Director, International Municipal Parking Congress.
The test we saw today in Scranton is going to prove very beneficial to all of the municipalities in this country who operate parking facilities. In that, I don't see there's any way that the insurers cannot take this into consideration in establishing rates.
Noreen Dan Martin, Executive Vice President, National Parking Association.
I've witnessed this morning here in Scranton visible proof of something we've known in the business for a long time, that a fire in one car in a modern self-service parking deck remains confined to that car. We had a strong wind blowing today, so that the likelihood of things catching fire near the car was heightened by this wind, and as we all have seen, neither car was really in any danger for the first 15 or 20 minutes of the fire, during which time in a city like Scranton, the fire department would long since have been here to put out the burning car. It was a spectacular morning, largely because of what didn't happen rather than what did happen.
What then was shown by this unique fire test? It confirmed what had been revealed by previous tests conducted in Japan, England, Switzerland, and at the Fire Bureau training ground, that an automobile has a low combustible content. Much of this combustible material is in the interior of the car or contained in the gas tank. For this reason, there is little chance of the fire spreading to adjacent cars before the fire department arrives. The test further demonstrated that there was no buildup of smoke or heat in the open-air parking structure. It also confirmed that the fill pipe and fuel line provided sufficient pressure relief during the car fire to prevent explosion of the gas tanks. Only 2 quarts of gasoline remained in the tank of the burned car after the Scranton test was over. Throughout the entire Scranton fire test, the exposed steel in the open-air parking structure remained undamaged by flames or heat. Maximum temperature of the steel girder was only 440 degrees Fahrenheit. This is much lower than the critical temperature allowed for steel beams and girders in the standard fire test E119 of the American Society for Testing of Materials. After the test, it was necessary only to steam clean the smoke deposits from the concrete slab in the test area and repaint the girder. The test area was open for business as usual the next morning.